Welcome back. We're going to talk about perpendicular lines. And since my last video, I did a lot of contemplating, breathing, communicating, and now I'm back. So we're talking about perpendicular lines. Yeah, go ahead and draw these out. I have line NP, and I have the equation, and I have line QR, and I have the equation. And something special about those lines. They are perpendicular. Who remembers what perpendicular is, though? Yes, Elizabeth?
Two lines that intersect that have an angle of 90 degrees.
Yeah, and I was happy that my lines actually look like they might be perpendicular. So they form a right angle. Close. Not just opposite. Opposite.
Well, they're negative too.
Reciprocals. Yeah, so we say negative reciprocals. Because if we just say negative, then it just becomes positive 3, negative 3. But it's actually negative reciprocals of each other. Do you guys see how I graph those? Are my graphs accurate? Like I started at the right place, I went up or down the right number of times, left to right? Am I good on that? Yes, I hope so. I hope so too, by the way. Okay. While you're doing this, I want to give you some heads up on geometry. How many points are in a line? Infinite number. But I'm going to call it line NP and line QR because you can say this is a line that contains the points N and P. So does this line, the green line, contain the points N and P? Yes. So I can call it line NP. Are there any other lines that contain N and P? No. Only one line, and that's the green one. What about Q and R? Does this line right here contain the points Q and R?
Yes.
Yes, Q and R. Are there any other lines that contain Q and R? No, nowhere in infinity will any other points on my graph contain Q and R. That's the only one. Okay, so those are my two lines. And what are you looking at when you see the equations? What's the relationship between perpendicular lines? I said it already. Yeah, they're perpendicular. But what about the equations? Look at the numbers. Study the numbers. Cole? Close. There are reciprocals and... Okay, good. They do have different y-intercepts. That doesn't always happen though. But there's something really specific.
One slope is negative, one's positive.
Okay, so not only are they reciprocals, but they're opposite signs. Perpendicular lines we call them negative reciprocal slopes. Man, that's a mouthful. Negative reciprocal slopes. But what if one's positive? Yeah, it's still negative. It's the opposite of the other thing. And we're going to investigate this next problem here. That's key. Negative reciprocals. Very fun to look at and to deal with and to use and to graph. Okay, so my question is, y equals 4/3 x minus 1. Is it perpendicular to 3x plus 4y equals negative 8?
Yes.
How do you know? I need proof.
If you do the A.
Okay, sorry, what's the slope here? How about that?
4/3.
Great, 4/3. It gives it to you right there. What's the slope here?
Negative.
Cole?
3/4.
Negative 3/4. Negative 3/4. Okay, are these two numbers, these two slopes, the opposite and reciprocals of each other?
Yes.
Yes. So here, positive 4/3, negative 3/4. They are negative reciprocals of each other, and therefore they are perpendicular. You want to know a fun fact about those two numbers? Super important to know. Negative reciprocals. This is something that's extra, but I think it's important to know. What is 4/3 times negative 3/4? Negative 1. If you don't remember negative reciprocals, blah, 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 these two slopes have to multiply to always get me -1 if they're perpendicular. So if they multiply and get me -1, they are perpendicular lines. Okay, great. Oh my, oh my. Can someone read that for me? Because I'm having trouble. I'm getting older. Yep.
Line ST is y equals 5x minus 1.
Thank you. And then the second line, you can read that for me. Jake.
Line UV is 10x plus 2y equals 12.
Thank you very much. And then, I even forgot this. The last line. You can read that last line. I think Parker can. Sophie?
Is line ST
Upside down. Upside down T-pose.
perpendicular
Yeah.
line UV.
This sign right here in geometry means perpendicular. So is line ST perpendicular to line UV? I don't know. What do we have to look at to know if two lines are perpendicular or not? Their slopes. So what's the slope of the first line? Do you know? 5. The slope is just 5. How do I know it? It's y equals mx plus b. Great. Get it in whatever form, whatever method you want to find out or use to find out the slope, you can use it. This one's straightforward. What's the slope, though, of the second line?
It's 10 over 2, which reduces to 5 over
No, it's okay.
Oh,
But
-10.
it's -10 over 2, which is equal to -5. Yay! What? That burst my bubble. Yes, ma'am?
When you're finding the slope, can't you just divide 10 divided by 2 and just make it negative?
Yeah. That's what we did.
And do you have to write it out though?
No, just find me it. But you get -5?
Yeah.
Yes, they are opposites.
No, they're not reciprocal.
Wait, that's picky.
Because they're both on sides of both.
Oh, they're parallel. Oh, I'm so sorry, guys. They're parallel, right?
No.
Why not? Okay, so ready? Are these parallel? No. Are they perpendicular?
Yes.
No. Because they have to be not only negatives of each other, but they have to be reciprocals. So here's a test. Ready? What's 5 times -5? -25. Not what we wanted. What do we really want? -1. That would have worked. So they're not parallel. They're not perpendicular. So guess what? They are
Lines.
they are lines that will intersect, but not at a right angle. So they can intersect like that, like that, like that, like that, but not like that, or like that, right? It can't be that. It can't be this, or that, or this. Okay, do you guys get that? They're still lines, and do they intersect?
Yes.
Yes. Actually, any two lines that are not parallel must intersect. How do I know that? Because what are parallel lines? Parallel lines never intersect. So they will never intersect, but every other type of line will intersect with each other. All right. Uh-oh. This sounds like something we did already. Yes, ma'am?
What about points that lines that have stopping points?
So those are not lines. Those are segments. Segment. Thank you. But yeah, if you have a segment, they may not intersect because they end. Or raise. They start at different points. Yeah, that happens. But anyway, I need you to find an equation of a line that's perpendicular to this line and passes through that point. Okay, what do you think I need first? The slope. What is the slope of this line? 1. The slope of the original or the given line is 1. What must the slope of my new line be? I heard one person. Be bold. Has to be -1. Wait. I thought we had to have the negative reciprocal. Remember, guys, what's that little test? What's 1 times -1? -1. So that fits. They are negative reciprocals of each other. So I know it's this format. Do I know the y-intercept?
No, but you can put it in point slope, right?
The return of point slope? That was on my last video, like many time periods away. Something like that. Yes, ma'am?
Did you mean negative 1x plus b?
I did. Thank you, Mandy. I was test.
Are you sure with that?
I think it was the board, Mandy, that made me write that. Okay, anyway, yes, it's y equals negative 1x plus b. I need to find b. I don't have b. This is not the y-intercept. How do I know it's not the y-intercept? Somebody else other than Cole, because he said it last time. How do you know this is not the y-intercept?
X is not 0.
Yeah, x is not 0. Oh, it's so close, but it's not, so it doesn't count. How do I find out that equation? What's that form? Someone called it out. Point slope. I love point slope. In fact, you can actually use any form to find out that equation, but we'll do point slope because it's so nice. Y minus y sub 1 equals m times x minus x sub 1. What's m?
1. Negative.
Negative 1. Okay, what do I get on this left side? Yes, ma'am?
Well, is this the part where you switch the signs?
When you're doing point slope, you're almost switching the signs, yeah. So what do I get on the left? Y plus minus 4. Because what's 4? It's plus, so I put minus 4. And then x.
I thought you said you were changing plus positive.
I am. You see how it's positive 4, now it's negative 4? And it's negative 1, positive 1. So here's your equation in point slope form, but that's not what I wanted. I want slope intercept form. So do you know how to get it from there? What's your first step on these problems? Like, I know this is complicated, but what do I want to get rid of? I want to get rid of the parentheses, so I distribute. So I'm going to get y minus 4 equals, distribution right here, negative 1x minus 1. Yay, it's in an in-between form. This is no form. Yep, sorry? Add 4 to both sides. And I get y equals negative 1x plus 3. Is this line right here perpendicular to the original line? Like, do you know that, right? But does this line pass through that point?
I don't know.
Graph it. Last graph today. Well, last graph with me. Graph them. You got to graph this line, you got to graph that line, and see if they really are perpendicular. How do you do that, Mr. A? Just graph them on the same line, the same coordinate plane, and see what happens. So, and this gets us practice with graphing because we do need that. Yes, ma'am?
Up one to the right one? Or
This one?
yeah.
Yeah, up 1, over 1 to the right. Yep. A 4 by 4 by 4 by 4 should be nice. Or you can do an 8 by 8. Or you can do 4 times 2 by 4 times 2. Yeah, I meant 2 to the second power times 2 by 2 to the second power times 2 minus 0. Let's do that. All right, I'll graph the first one. Positive 2, up 1 over 1, down 1 over 1. So that's my given line, and then the new line, positive 3, 1, 2, 3, down 1 over 1, down 1 over 1, up 1 over 1. Oh, thank you. Pretty close, but are they perpendicular? Are they perpendicular on your line, on your graph, sorry?
No.
Okay. You know why they're not? Okay, do you know why mine aren't always perpendicular or parallel like I like them? It's because my spacings are not correct. Like I spaced one way too wide, and then I made these smaller ticks, and that throws it all off. But it should look pretty close to this. Does my new line, which is this line right here, this is the new line, does it cross through negative 1, 4? Let's see. Negative 1, 1, 2, 3, 4. Does it go there? So it is a perpendicular line through that point. Fun facts. Sorry? I would.
Fun facts.
Fun facts for the day. They are fun. Because if you know them, it makes the problem fun. If you don't know them, they're not
I
so
feel like it
fun.
wouldn't change.
It would. It makes your life easier if you know these fun facts. So fun.
But they're not facts, Mr. A.
Even more fun. So see, you get it? Okay, I'm going to bring them down here. The first fun fact: horizontal lines are parallel to one another. So if I have a horizontal line, another horizontal line, what do I know about those two lines? They have to be parallel. And you know why they have to be parallel? What's the slope of any horizontal line? 0. So if this is a 0 slope and that's a 0 slope, guess what? They're parallel. Fun fact number 2, vertical lines are parallel to one another. Look at that. What's the slope of a vertical line?
Undefined.
Undefined. They're parallel. But the third fact is even more fun. Funner? Is the funnest. Any horizontal line is perpendicular to any vertical line. I hope that makes sense. If you have a vertical line and you have a horizontal line, what do you know about those two lines?
They're going to intersect.
Yeah, they're going to intersect and it's going to form a right angle. So that's perpendicular by definition. This is a brain teaser, and if you're listening, you might get it. That means that 0 and undefined are negative reciprocals of one another. Try to calculate that one. Okay. Yes. Your homework. 2 to 12 even. Pages 121. Yes, I can. 2 to 12 even. Pages 121. Can someone, like maybe Sydney right there? She's nice. 2 through 12 even. All right, and that's pages 121. Goodbye, Swivel, again.